your work is on robotics and AI problems related to medical surgery. Can you tell us a bit about what this kind of work and research entails?
The surgical instrumentation has changed dramatically over the last 20 years or so. And so now you've got advanced instruments that are robotic, so they can articulate as if you've got miniature hands inside the body. So that's the robotic part. And increasingly over the last 10 years, you're getting AI systems to provide assistance. So helping the surgeon or clinician to see specific structures that might be relevant to the operation, or to recognize anatomy, to understand what people are doing. So kind of assistive computing systems. So we've really kind of been focused on one, developing new devices, so new robotic devices, and two, building a variety of AI algorithms that might be able to link to those devices or be used as standalone kind of software as a medical device.
And you're a professor of robot vision.
Yeah,
So,
that's right.
yeah, what exactly expertise-wise from this robot vision area do you bring into your work?
I did my PhD in computer vision, so it's a specialized part of AI that deals with the way that people see, and trying to replicate that in computers. So the human visual system is an extremely advanced intelligence system and sensor. So our eyes are a very great sensors, and they help us navigate our environment, they help us make decisions and so forth. And computer vision has been focused on creating computing systems that can replicate some of the function of the eyes. So can you build systems that help a computer to detect objects, or to understand motion, or to map the environment? And so you see a lot of these systems in use today. They exist in our mobile phones or in our computers, but they're less present in the surgical operating room. So what I've been focused on, I did my PhD in this, and I have continued in that area, is building systems that are able to do this type of activity in surgery. So if you're doing a surgery using a camera, which is increasingly the case, so you can have cameras that are microscopic to do microsurgery. This happens on the eyes or on the brain or in various other parts of the anatomy. Or you have cameras that are endoscopic, so you have a miniature camera at the end of a stick or on a flexible device that's inserted inside the body. So that's really the key information that the surgeon gets from the operating site. And I've focused on developing algorithms that can take those images from the surgical site and try to build understanding. So try to build intelligence on top of it.
Yeah, you've got like robotics and AI. Obviously, there's an overlap between these sometime, but could you maybe talk about like the extent to which, at the moment at least, like robotics is helping in surgery and AI is helping in surgery, and then obviously how the two come together as well, if we can divide them up and like bring them together?
Robotics is helping in surgery by creating better instrumentation. And this is particularly the case in minimally invasive surgery or keyhole surgery. So one of the classic problems with keyhole surgery is, for example, if you're holding a surgical instrument that's elongated, typically it's inserted into the patient around a trocar, so a point where the instrument moves in a fixed position at the tummy, for example. So when the surgeon moves down, the instrument actually moves up. So your hand-eye coordination is completely reversed. And in addition to that, you don't actually see inside the patient. You've got a camera showing you what's inside the patient. So you're kind of separated from where you're operating. And the reason for that is to reduce the trauma so that you don't put your hands inside the patient. But the instrumentation component becomes very challenging. So it takes a lot of training and a lot of expertise to maintain that training. So robotics has really been used to enhance the ergonomics of that operating setup. So to enable the surgeon to sit comfortably on a console, to manipulate the instruments using ergonomic joysticks, and then those instruments to be inside the body and to have full degrees of freedom, to have aligned hand-eye coordination. So that's really the robotics component of, at least in minimally invasive surgery. There's other robotic systems that are used for orthopedics, for example. And so those are hardware instruments. And most of those feature a very limited amount of AI, if any, or AI in the way that we see it today. They obviously have a lot of software, a lot of algorithms, and so on. But it's really kind of very dexterous, advanced instrument. So that's what robotics in surgery is today. And then AI in surgery, there's very few systems that are actually used during a surgical procedure. Some of the most prevalent ones are in diagnostic procedures. For example, in an endoscopy, you can get systems that can detect polyps or cancer. And they're used as assistive systems. So the purpose there is, can you get everyone to have the same level of efficiency of, for example, detecting cancer or understanding a particular structure. And I think the role of systems like that is going to be to kind of ensure that that cancer isn't missed or that particular risks are mitigated, but it's still much more nascent. So with robotic surgery, you probably have millions of procedures being performed every year. With AI-assisted surgery, the numbers are far less, but are likely to grow and probably overtake at some point.
Has the extent to which AI has been used, although nascent still, early stages, increased much in the last 5 years? There's obviously a lot of talk about AI advance, and some of it's hype, obviously, but has too much changed in the last 5 years?
I think it has, but I think it probably will change even more over the next 5 or 10 years. So typically, technological advances happen in areas outside of medicine first, and then they enter medicine, and then they enter surgery where maybe some of the risks are higher, or kind of the safety checks, or the way that the device is developed, it just has more onerous precautions around it. So I think the really exciting kind of AI-assisted tools are likely to emerge over the next 5 to 10 years. But yes, there are systems out there that have appeared over the last 5 years as well. So I think the key things are that data in surgery is much more complicated to manage. So getting a sufficient amount of data to build your AI systems is still a challenge. Ensuring that data represents a diverse set of populations so that your system performs without bias is another challenge. In the way that data is governed across different regions around the world is another challenge, and so on and so on. So I think those are the bits that, even if technically we're able to do it, I think there's logistical challenges in terms of translating this into a device that can be utilized internationally on patients.
And you're the director of the acronym, is it the WEISS Center? How do you?
Yeah, that's right, the WEISS Center. So it's a bit of a mouthful when you say all the words. So it's the Wellcome EPSRC Center for Interventional and Surgical Sciences. So we shortened it to WEISS, although we're soon going to change the name because our funding model has changed.
And that's where we are today. We're in a room in the center. Am I right? This is kind of like a multidisciplinary center. You've got engineers, clinicians, scientists, different people here. What exactly do you get up to here?
Yeah, that's right. So the whole the mission of the center was to combine expertise from the engineering faculty at UCL with the clinical expertise from the life science and medicine faculties, and to do this in order to get some of the fantastic engineering work that we've been doing to be translated into meaningful solutions that can help patients. So the center is built with that mission in mind. The whole building is shared between medicine and engineering. So on the top floor, you've got the Department of Surgery, you've got radiologists in the building, and then you've got engineering labs. And so the co-location is intended to help both strategic collaboration and also kind of organic. You met in the lift, you discussed the cool project, and now you're able to go off and do it. And it's been fantastic. So we've been running for about 7 years now. And it's resulted in some really interesting work, some devices that are now available internationally, lots of clinical trials. So loads of really exciting work that will hopefully lead to better patient care.
Can you give us some examples of those devices that you've some have been used worldwide now?
Yeah, so myself and the clinical director of the center, Professor Lovett, we were working on AI systems to improve endoscopy. We developed the early stage research, so building the algorithms and the computer science behind it. We got clinical data. We could see that these systems were beginning to actually be translatable, so to be able to actually help patients, to the point where we thought it was the right time to form a spin-out company. So we formed a spin-out company, and that spin-out company is called Odin Vision, is now actually part of Olympus, and it has devices that are regulated on the European market and have been used in many patients in order to assist detection of cancer.
What is the kind of medical community's response to increased suggestions and usage of AI and robotics? To most surgeons and physicians, radiologists up for this? Some people ever skeptical of certain things?
It's a great question, and it's a complicated one, and probably you need a clinician like Lawrence to be able to answer it. But I think it's mixed. I think there's a lot of excitement. So I think. If I think about 20 years ago when robotic surgery was nascent, I think there was a lot of apprehension of, is our robots going to become autonomous? Is this going to, take away jobs? Is it going to be safe for patients? Is it economically viable? These systems are expensive. Is it improving care? And when I think about the state of play today, for certain specialties, it's the gold standard. If you're having a prostate cancer surgery, it's very likely that it would be done using a robotic system. So acceptance and adoption has dramatically changed. And so I think clinically, in the surgical specialties, I think everyone is aware that robotics is very much here to stay. And robotic instrumentation, the form factor, the way that they look or the way that they're designed may change, but it's very likely that the essence of having articulated instruments that can do things that much more advanced things than a standard manual instrument, I think that's very likely to remain. And with AI, I think the trend is similar. I think a lot of the kind of progressive clinicians see it as an opportunity. It's going to be a tool that enhances the way that certain things can be done. I think it's really important to be specific and to be able to articulate what the clinical value is. So using AI for the sake of using AI is obviously not going to be very valuable. But if it helps you in pathology to go through huge amounts of backlogs of data in order to be able to reduce the burden of having to label slides, or to reduce the time that a patient waits for their diagnosis. In radiology, if you're able to do the diagnosis in an assisted manner using these systems, again, alleviate waiting lists, do things efficiently, do things really accurately, have a standard of care so that you don't get a variation of whether you're being treated at a very large teaching hospital or at a very small community hospital. So I think those are some of the opportunities, but they really need to be specific to the clinical indication that's being treated, be able to articulate a value that is, in the end, is helping the patient. And so I think we're not there for all of these things, but I think the opportunity is there. And I think some of the concerns are really about data, about equity, about bias, which I think they're natural, but I think we're on the road to being able to address some of them.
If you imagined, let's maybe take a couple of examples, 5 years and then maybe 10 years and then 20 years out from now, what would be some kind of dream use cases you could imagine that would be actually used in day-to-day now in surgery with AI and robotics? So a few years and a decade and a couple of decades.
In a few years, I think most kind of surgical imaging systems are going to have some form of AI in order to assist you to prevent risk or to try to flag up something that you didn't see. Maybe you're too focused, or maybe you haven't seen a particular case. I think it's very likely you're going to have systems that can do things like phone a friend. You know, the AI component of that system may be very small, but the digital platform to enable that might be quite important. So if you're unsure, you might be able to get additional advice. So I think systems like that are going to exist in the next sort of 5 years. 10 to 20 years, I think predicting what's going to be happening in 10 years' time, you probably got a 1 in 10 chance of getting anything right. But I hope that some technology is going to enable treatment to be more accessible. So actually today you've got very large numbers of people, I'm going to say billions, but huge numbers of people that don't have access to safe surgery. So I think maybe creating some of these devices may enable diagnosis or even surgical care to be performed to those unserved populations. I think that would be really exciting. And the way that happens in, for example, in the UK and in the NHS might be very, very different to the way that it would happen in a low to middle income setting. So maybe for us here, it may mean that certain things might happen in the home. So instead of having to go to a GP or to a hospital to get a diagnostic test, or that may be accessible to you in the home, I think that would be really exciting. And in other settings, the way that it happens maybe slightly different. But I think those are really the big opportunities. And then, of course, standardizing the treatment or ensuring that you're getting the best type of treatment. I think that also, it's not just the technology. I think it also involves a lot of policy, a lot of healthcare economics. So I think there's a lot of questions there, but I think that's something else that I think in 20 years time we'll probably have better standardization, so that if you're getting a particular type of recommendation for surgery, that it is what we currently know is the best practice for you to have that surgery. And I think today there's huge amount of variation of that on the global setting, so that if you go and have surgery done in, I don't know, in Brazil, it may be a slightly different approach with different instrumentation, with different choice of practice to what you would have in the UK to what you would have in the US. So I think understanding the scale of variation, how different populations benefit from certain approaches, I think we're on the road to being able to understand some of that, and I think that's going to be there in 20 years.
Yeah, those two examples you gave are really interesting. The first one, the kind of phone a friend idea, is this some kind of voice-enabled chat GPT system where you're basically saying you can kind of ask for advice in the moment during an actual surgical procedure to get some advice?
Exactly, it could be. So, I mean, I saw some recent work from NVIDIA and Berkeley, and they were using large language models, like ChatGPT style models to not only to do that, but then to also enable the action for a robot to, pick up a needle or to actually take some sort of action at the surgical site. So I think systems like that are likely to emerge. Whether the phone a friend function really needs a large language model, or whether it's just the hospital needs to have great Wi-Fi and you need to have an expert group at the end that is able. So I think we don't know that. I think that's something that we need to figure out. But I think many surgeons have probably had to, either during training or during practice, have probably had to resort to kind of more commercially available systems like Zoom or Facebook or something like that in order to get a functionality like that. I think we're now at the point where we may be able to build it in a much more bespoke, more designed for the right setting type of solution.
And the other example you talk about perhaps being able to do certain things at home that you typically have to go to a hospital before. What's an example of what that could be?
You've got swallowable systems. So instead of having an endoscopy or a colonoscopy, you may be able to swallow a capsule and it just travels through your GI tract and diagnoses you. You may be able to take a picture of a lesion or a wound or of a skin condition and get an automated diagnosis or referral. So for certain diagnostic tests, for example, you want an exam on your eye, instead of having to wait for 6 months for a consultant observation, you may be able to just do this using a web link. So I think there's systems like that may have some component of AI in the background, but the infrastructure really needs to be there to enable that to happen.
Yeah, and the kind of robotics and AI that's used today in surgery often seems to be, obviously surgeons are the front and center of the operation, and this is kind of a system. But can you imagine a future where increasingly the kind of the work is just given over more and more to the machine? And could you ever imagine essentially, I guess, a surgery, where it's completely operated by a robot with no human intervention apart from perhaps just some oversight and checking? How possible is something like this, and how much would we maybe even want to try something like that?
Complicated question, and I'll probably get my answer wrong because there's lots of different considerations. So I think at the moment we have other problems that are more important for us to fix than automating surgery, unless, for example, you need to do surgery in space, where you might not have a surgeon, or on another planet, or in a setting, in a hazardous setting where the surgical care it just cannot be delivered in a conventional way. So I think those are really the use cases for automation that appeal to me. Otherwise, I think I'd rather we invest in improving the outcome of an operation rather than making it autonomous. In addition to that, the investment required to make surgery autonomous may be huge. It may be enormous. There may be enormous kind of user challenges in terms of adoption. There's questions around liability. There's questions around, surgery is a very important part of the treatment, but the aftercare in surgery is also really important. Making the right decision of which surgical procedure or how to perform the surgical procedure is also really important. So I think healthcare is very complicated, and I think choosing to invest all of our kind of capability in automating one component is maybe not what I would do. In addition to that, I think automation, even if it comes, is very likely to come as a subset of small features. So rather than automating a full procedure, you might have like an automated assistant that moves a particular instrument for you, or that moves a camera for you. And I think the questions there are really, why would we do that? Is that in order to improve efficiency? Is it to improve the throughput of how many procedures can be done? So I think we should just always bear in mind, like, what is the patient benefit going to be for us to develop this technology?
Yeah, it's interesting because you said earlier about, how sometimes people just use AI for AI's sake. And could you imagine that maybe some organizations will try and push this higher degree of autonomy from the robot perspective as a way to maybe sell things? And this would just be concerning because, as you say, what actually matters is this actually helping the surgery? But often things can look impressive but not actually be helpful, right?
I think there's always a risk of that and an element of that. I think the problem with that approach in healthcare is that in the end, adoption really needs to be driven by outcomes. And so you wouldn't get, for example, in the UK, you wouldn't get a body like NICE, which gives us our recommendations for what is best practice. They wouldn't be based on hype. They would be based on the evidence that these systems are producing. So I think some organizations may use that in order to generate sort of market interests or to get interest in their products. But I think any upside of that would be short-lived if it's not then linked to actual benefits.
Okay, then to kind of understand a bit how you got here, how you're the director of this center and doing the work you do, I'll go back in time a little bit. So, what were you interested in as a teenager? Could you see any? Can you plot the path for maybe any early interest to being here, kind of pre-university?
Not really, actually. I was always interested in maths, but I would say I was equally interested in art, and and I remember my parents taking me to university, and me being very annoyed that I was going to study electronic engineering when actually I wanted to study architecture. And I remember my dad at the time sort of laughing at me and sort of saying, "Well, you've made this decision. You're coming here to do this. Like, why are you having a tantrum?" So I definitely wasn't set on a particular kind of path early on, and even studying engineering, I thought I would probably leave university with my engineering degree and go and work in a corporate job or do something like that. So totally unexpected where I've ended up.
Why didn't you choose architecture in the end then?
I don't know. I think it was, although my dad was laughing at me, I think a part of it was, I was born in Bulgaria and we came here when I was 11 years old, and when it came to choosing A levels, I was a little bit undecided. I was thinking about maybe law or maybe architecture, and then my dad sort of said, "No, do engineering. Good engineers always will have a job," and sort of that probably played some part in it. But also, I clearly didn't feel strongly enough to pick a particular path, and so I did very, very kind of analytical A levels, and it's all worked out well somehow.
You still interested in art?
Yeah, definitely. Last Christmas, my partner got me some art and crafts presents. I haven't got around to using them, but the intent is still there at some point in my spare time to do some.
Any particular kind of art that you like the most?
I was really into charcoal drawing, so I really like that. It was quite abstract. I did an A level in art. I didn't finish it by the end, but I was quite into abstract art. These days I really haven't dedicated too much time to it, but I'd love to revisit.
Yeah, and talking about your degree, so you did, I believe, electronic and computer systems engineering in London at King's College London, and then did a PhD at Imperial. Can you say a bit about your PhD, what that research involved?
Yeah, so my PhD really was doing computer vision in surgery, which is what I still do today. At the time of starting my PhD, I knew nothing about this topic. I didn't even know it existed. I was going to do, so in my undergraduate degree, I'd been working with a professor at King's to do computer vision for surveillance systems. So we were actually he was interested in working with surveillance in tube stations and in railway stations. And I remember going to a meeting with the Heathrow Express, who were interested in using, we call it AI now, we didn't at the time, but they wanted a system to automatically analyze the images in the cameras at Paddington and to tell them how many people were queuing up at a particular desk. So to understand load in the station. And so I was kind of thinking about working on that. And then the professor I was going to work with decided to move. King's reorganized the department. And I didn't want to move to Newcastle or to wherever he was moving. And so really opportunistically, I went and spoke to somebody else at Imperial. And he said, well, have you heard about surgical robots and doing AI in surgery? And sort of my eyes opened wide and I was like, oh my God, this sounds incredible. So that's how it all started for me.
So it was really just hearing from him this suggestion of robots in surgery that made you think about it? Or was there any thought about doing that before?
No, I really hadn't thought about the medical aspect before. I just wasn't aware, I think at the time the internet wasn't as populated with information as it is today. I just wasn't really even aware of what the medical profession was doing or how this technology like this could impact medicine. And so this was really, I think it was the first robot in the UK, commercial robot to be used in surgery. It was being used by my clinical supervisor in St. Mary's Hospital. And then technically we were thinking about what sort of technical work could we do around systems like this. So yeah, it was really the first time I'd heard about it, the first time I'd thought about it. It sounded incredibly exciting, and it sort of really made me think, oh, wait a minute, maybe systems like this can actually have a really positive impact on human life or on human healthcare, and that really got me excited.
Yeah, is it that positive impact that's made you really enjoy this work? Like, why exactly have you stayed in this field, enjoyed this work, been so motivated to do it?
Yeah, it's definitely been that positive impact, and also it's incredibly intellectually stimulating, and then going into an operating room, seeing patients that are treated by the clinical teams, it's incredibly humbling. And so the opportunity for your research, which is intellectually stimulating, to have an impact in this setting, there's nothing like it, in my opinion. So that's really been the key motivating factor.
Could you imagine working in any other kind of high impact area from robotics or AI that you think is important that isn't medical? Is there anything else you see out there that you think that would be really important to work on as well?
Yeah, there's lots of things. I get excited by lots of different tech and tech opportunities. There's loads of exciting things in sports, in rehabilitation, in entertainment. Unfortunately, you've only got so many hours in the day, and so I think now I'm at the point in my career where I've invested so much time and energy in a particular direction that for better or worse, I would find it very difficult to move into a different direction. But maybe that's just a lack of bravery. Maybe one day I'll change my mind.
I mean, yeah, one example I wanted to ask you about actually just briefly was Neuralink, and not just Neuralink itself, but also they have this robot that I think does, at least the plan was to do it or something, is the robot that inserts the electrodes into the patient's head. Just intrigued by your thoughts on Neuralink generally, and then specifically if you've read much about any of like the kind of robotics behind it and what they do to insert things.
So I don't know very much about Neuralink at all. I remember seeing work, it must be about 20 years ago now. It was happening in California and in Berkeley around implanting sensors that could then get the stimulus from a signal in the brain to a muscle, or there was other really interesting work around if you had a severed nerve, you could implant a sensor on either side of the nerve, and the nerve would over time start rebuilding itself to rebuild that connection. So I think it's fascinating, and obviously can have a huge impact on populations that really need systems like this. So I don't know very much about the technology, but it's extremely exciting. In terms of robotics for neurosurgery and for implanting things deep into the brain, there have been a number of systems. I don't know what Neuralink are doing specifically, but I guess the key challenge is inserting something into the brain with minimal damage to any of the other structures, so that you don't impair the patient in any way. The advantage is that you've got high field MRI systems that are able to image deep into the brain in a very, very efficient way. So you'd be able to do this planning. And then the challenge is how to adapt the path of the electrode insertion or whatever they're inserting to deal with any changes as you're pushing inside the brain and things are moving and deforming. How do you make sure that you're still keeping any relevant structures intact? So how do you adapt this plan?
And just back to kind of your day-to-day work now, a couple final questions to understand what you get up to. So what is a typical week like, if there is a typical week? Perhaps there isn't one.
I think these days there isn't really a typical week. I think the difference between doing research earlier in my career and today is that I think my role now is much more an advisory role. So I think I tend to manage people and steer PhD students and kind of the direction of the research, rather than do the day-to-day analysis or kind of coding and so on. So I think that was difficult to let go of doing the hands-on work. But I think nowadays I tend to have a lot of meetings, too many meetings probably, do a lot of traveling, so I've just become a parent, and so that's thank you. So that's going to be something to balance out, as in how much I'm able to travel, and then I try to get into the labs as much as I can, and I think the exciting bit is still going to theaters whenever there's an opportunity. So there isn't really a typical week, a very mixed.
When you go to theatres, it's just sort of observe the technologies in action whilst an actual operation is happening.
Yeah. It's for that. It's sometimes for data collection, and sometimes it's especially when working on a new surgical procedure or in a new setting, it's really to kind of understand what the workflow is, to really understand what may be possible there. So I think it's still really eye-opening, seeing actual clinical practice.
Is there an incredible amount of research you have to keep up with, like the latest papers? Is there a way you do that? Or as you say, maybe it's more of a kind of management role you're in these days, less in the weeds or of the...
Yeah, so I mean, obviously I rely on the team to keep up with some of the very specific details, but the field has grown. It's sort of exploded. So one of the main conferences that I attend, MICI, the number of papers that get submitted to it has kind of doubled every year for the last few years. So suddenly the number of papers that come out is just it's incredibly large. Some of the other computer vision conferences, you have like many thousands of papers appearing, so it's very difficult to keep on top of it. And it's hard to know what bubbles up to the top, and you see things that make a splash in the media. Is that the most relevant work? Is there other work so I think you need to be in the weeds of it to really understand the field in a deep and meaningful way. But it's almost impossible to stay on top of everything.
I was going to ask you about your personal life, what you get up to outside of work to relax. I guess at the moment you're a bit busy with your new child.
Yeah, at the moment I wake up every morning to somebody wanting to feed. So that's obviously that's a new change in my personal life. Otherwise, I like to play squash as much as I can. Do a lot of kind of running and cycling. I still cycle everywhere in London, and like traveling and sort of normal things, going to the pub and going out for a meal, that sort of thing.
And as just a final question, perhaps you can maybe connect this to your career, in the kind of value of doing important work. I won't put words in your mouth though. I basically ask every guest, at the end of an episode, what they think about something, which is, what do you think it means to live a good life?
It's probably different for every person. I think for me, I think feeling valued in what I do is quite important, and so I think this notion that the work that I'm doing actually has an important contribution to society or to healthcare is valuable to me. I think that's important for me, and then the rest is probably sounds a little bit banal, but seeing my family happy and my friends and the people around me, and being able to spend some time with them and kind of appreciate that time, that's also really important. So I think for me, that's a good life, but I think it evolves as you over the years, and it's kind of it's difficult to keep a finger on the pulse sometimes. It's easy to get trapped into kind of ambitions or various professional activities and kind of really focus on that, whereas in reality maybe that isn't the most important thing to you. And it's kind of good to self-check sometimes.
And I think some of that banal sounding stuff is actually some of the best, really.
Yeah,
Dan, really enjoyed this. Thanks so much for your time, and keep up the great and important work. It's clearly very valuable what you're doing.
Thank you so much. Cheers.
I hope you enjoyed this conversation. If you enjoyed the Human Podcast, please consider subscribing. I hope to see you soon.